Alright, as we look at our due down today, it's asked what the surface area of the shape below is. So there's really two different methods that we can go about completing this particular task. And one that we've talked about is finding the lateral area and then the area of the two bases. So if we look at the lateral area here, we might say that the lateral area is kind of the distance around the sides. So our lateral area, remember, is the same thing as kind of, it'd be this long rectangle made up of all of those sides. Sorry, this is kind of a mess. And if we come around, those sides would be like this. We'd have, okay, this front one is 8 long. This one would be 7 long. Next one would be 8 long. And the back one would be 7 long. And they'd be 12 tall. So it's like one big long rectangle. And we could say that this is 8 plus 7 plus 8 plus 7 is 30 by 12. So our lateral area is equal to 30 times 12. Because it's one big long rectangle, which is 360. And in addition to that, we need our lateral area, so our surface area is equal to the lateral area, and then we need to add in the two bases. So we've got one base here, and then we'd have another one down here. So we have 2 times the area of the base. Well, the area of the base is a rectangle. That is 8 by 7. So that's equal to 56. So our lateral area, 360, plus 2 times 56 would be equal to 360 plus 112, which is equal to 472. And our units, square centimeters. Alright, so in order to wrap this entire box up, we would need 472 square centimeters of wrapping paper or material to cover it up. Alright, let's move on to our aim for today. Alright, today's aim, Kipsters, will be able to find the area of a, today we're moving on to find the volume of a prism. Alright, volume. So we've got to talk about volume. We're going to remind ourselves what volume is. We're going to spend a little bit of time just kind of re-exploring kind of the volume of a prism. Volume is how much three-dimensional space, or how many cubes can fit in a three-dimensional space. So exploring volume, let's start with our definition of volume. Volume is the number of cubes that fit in a 3D space. Discuss with your teammates really quickly what is the difference between volume and surface area. Those are two concepts that are very often confused, so please go ahead, pause the video, take 30 seconds, and discuss with your team what's the difference between volume and surface area. So as you discuss the difference between volume and surface area, we're talking about surface area is the number of flat squares to cover a three-dimensional shape, and volume is going to be talking about the number of cubes that fill a three-dimensional space. So we're thinking about the difference between, how much wrapping paper to cover something up and how much can I fit into that particular box. All right. So what is the area of the figure to the right? So how many flat squares? So we're not talking about volume quite yet here. What is the area of this particular shape? So you and your team should recognize here that this is a rectangle. So our area of this particular shape is going to be base times height, or 6 times 6, which is 36. Now, the next thing we're going to do is we're going to go ahead and take that same flat area and we're going to make that the base of a rectangular prism. All right, so go ahead and build with your group one set of cubes, or one flat panel that is 1 unit high that happens to have that base. So we're looking at our prism here, and we can see that this prism still has a base that's exactly the same, 6 by 6, and it is 1 unit tall. So 1 unit tall and the base. What is the volume of the figure to the right? How many cubes does it take to make up this particular shape? So looking at your volume, you're like, well, if I make this particular shape, I can see that it would take me 36 cubes to make up that volume. All right, so what is the volume if I add a second layer? So go ahead and add a second layer on. How many cubes does that require? So most of you are telling me that this is V is equal to 72. So how did you do that? Did you actually go through and count every cube? Discuss with your team, is there maybe a faster way rather than counting every cube? All right, what would the volume be if there were 4 layers? So is there a faster way to do that? So the volume would be equal to, what we should be starting to think about is man, I really don't want to have to recount that every time. But we know that every layer that we're putting on here, this first layer had 36, the second layer had 36, which means the fourth layer would have 36. So for this one, we'd be thinking about like this is 36 plus 36 plus 36 plus 36, which we could rewrite as, really this is just 4 times 36. Now if we're starting to think about this, and we see this visually, this is kind of like we have that same shape. We have that same shape and now we just have 4 layers. So this is now 4 units tall. So what we can see here is we're starting to build this idea that if I wanted this volume and I had H layers, well, what do I need to do? Well, each layer would be 36 times H layers. Or thinking about this, again, this picture would be, we have the shape here. It's H units tall, and the base is 36. So the volume of a rectangular prism is really just, we can see, going all the way back, it's however many squares fit in this base up here that we decided a long time ago how many squares fit in one layer times however many layers. So this is the volume is equal to the area of the base times the height. The height telling me how many layers there are. Alright, so that works for a rectangular prism. Let's see if we can explore how that would look with a triangular prism. Alright, so what would be the area of the same figure if we cut it diagonally in half? So we're going to take this and we're going to cut it diagonally in half. So we're going to cut it in, we're going to shade it out like this. Alright, so now the area that we're working with here is just this triangle. Well, what's the area of this triangle? So the area of this triangle would be equal to 1/2 of base times height, or 1/2 of 6 times 6, which would be 18. So think about it. If I took that and I wanted one layer of that, how many cubes do you think we would need in order to make that happen? Well, as I start to kind of look through this, what I can see here is as I'm cutting this in half, it's like I see 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 and a half because that one got cut in half, 16 because that one got cut in half, 16 and a half, 17, 17 and a half, 18. So once again we see the same idea that in order to make this, that the single layer is also the same thing as the area of the base. So the volume here is equal to 18. So what if I added a second layer? Well, that's just the second layer of the same thing, so volume would equal 18 times 2, which is 36. 4 layers. In your brain, you're thinking volume is equal to 18 times 4 different layers, which is going to be 36 is 72. And H layers, so again, don't know how many layers, is 18 times H. So again, we come back, and this is really just the area of the base. So the volume of any prism is going to be the volume is equal to the area of the base times the height. So again, how many cubes to make one layer times how many layers are there? That's the entire formula for the volume of a prism. And so we can use this idea no matter what the shape of the prism is, as long as we can count how many layers there would be, and we can find out what the area of each of those layers is. Alright, so let's flip on over and look at some more practical application here. Alright, so it says find the volume of the right triangular prism shown in the diagram using our equation that the volume is equal to the area of the base times the height. So remember, when we're talking about a base of a prism, it is the shape that has the exact same shape directly across from it, and it's the rectangles that are connecting the two bases. So identify within your group really quickly, what is the shape of the base in this prism? What is the shape of the base in this prism? If one of your teammates doesn't quite understand, please make sure that you show them and describe to them why the shape that you've chosen is the base of this particular prism. Alright, so when we look at this particular prism, the prism here, the base here is this triangle, and it is connected to its base partner, which I'm going to shade here in blue, by the rectangle. So it's like connected by these rectangles. So we know that this is going to be volume is equal to the area of the base times the height. So the area of this base, since it's a triangle, what is our equation for the area of a triangle? So you should be telling me this is 1/2 of base times height of the triangle times our height, or how long this particular prism is. So there are 6.5 layers. That's what this is telling me. If I were to take this and turn it on its head, there are 6.5 layers of this triangle. So the base and the height of just our triangle, so I'm looking at just my triangle now, is equal to 1/2 of the base is 4, and the height is 1/2, times there are 6.5 layers of this. So if I go through and I do all that multiplication, one way we can do this multiplication would be 0.5 times 4 times 0.5 times 6.5. If I go through and do all that multiplication, I'm going to get 6.5. And our units of volume is, we're talking about how many cubes it would take to fill it. So we're talking about centimeters cubed. Okay, centimeters cubed is our units here, or cubic centimeters. How many of these cubic centimeters would fit inside? Alright, so looking at the next one, it says calculate the volume of the solid using this, and it tells us all angles are 90 degrees. That's really just to tell us that this is a right prism, which means it's straight up and down. Alright, so looking at this, identify with your teammates. What is the shape of the base? So volume is equal to the area of the base times the height. With this particular shape, it is a rectangular prism, which means it has a rectangular base. Now there's a lot of different ways that you could look at this particular shape. Most of us probably think about the base being this shape up here. So our equation for the area of that rectangle would be base times height times the height, or how many layers of this rectangle are there going to be. In this case it's 12.5. So the base and height of our base here, and so sometimes it helps me, if I'm trying to find the area of my base, to just rewrite out and draw out what that base looks like. So for me, I'm just going to be like, oh hey, this is the area of my base. Alright, so base times height would be 7 times 8 times 12.5. Alright, I'm going to go through and kind of do that calculation on my calculator. And once I've calculated that, I get 700 cubic centimeters. Alright, go ahead and let's look at this one. It tells us that the piece of a stock metal being used to make hex keys is a long hexagonal prism. Alright, so we see a long hexagonal prism here below. Alright, it tells me that the base of the prism is a regular hexagon with 1 centimeter long side. The area of the hexagon is approximately 2.6 centimeters squared. The piece of material is 25 centimeters long. What is the volume of the figure below? Alright, so we look at the figure below. The figure below is a prism. Identify with your team. What is the shape of the base of this prism? So you should identify that with your team. The shape of the base here is this hexagon. It's a six-sided shape. Is the area of our, or is going to be our base. So volume is equal to the area of our base, so the area of that prism, or of that hexagon, times the height, or how long, or how many layers of that hexagon farther. So go ahead and fill in this information here. You do not need to calculate the area of that hexagon because it is given to you in the problem. Go ahead and see if you can't complete this problem really quickly on your own. So looking here, this tells us that the area of the hexagon, which is the area of our base, is 2.6 centimeters squared, so 2.6. And how many layers do we have? Well, if I was to layering up these hexagons, I'd have 25 centimeters of layers. So our volume is equal to the area of that base. In this case, it's given to us. We didn't actually have to calculate it. 2.6 times 25. Go ahead and throw that into your calculator. And you should get that our volume here is equal to 65 cubic centimeters. Alright, last one. This is a right pentagonal prism, and it's composed of a right rectangular prism joined with a triangular prism. Alright, so looking at this, it says to find the volume by combining the volume of the rectangular and the triangular prism. So really it's saying that the volume here is whatever it would take to fill this box that's here on the bottom. So whatever it would take to fill this box here on the bottom, plus whatever it would take to fill the triangular prism here on top. So here we need to find two volumes. We need to find the volume of the triangular prism and the volume of the rectangular prism. So the volume of our triangular prism and the volume of our rectangular prism. Alright, so let's start with the triangular prism. Area of the base times the height. See if you can't figure that one out on your own. Make sure that you're putting in your equation for the area of that base. Tell me how many layers that base is. And go ahead and fill in and find the volume of that triangular prism on your own. Then go ahead and find the volume of the rectangular prism and check back in to see if you found those. And then we just need to combine them to get the total volume. So make sure you pause the video to go ahead and find these two volumes of these two different prisms on your own. Alright, as you come back, the volume of our triangular prism, the area of the base, well, it's a triangular prism, so the base is a triangle, 1/2. And as I look at my triangle, just kind of redrawing my triangle off to the side, it is 1/2 tall. The base is 4. And then, so that's 1/2 of base times height. And then as I look at my triangle and I turn it into a prism, I can see that it goes 6.5 meters deep. So base and height are 4 and 1/2. We've actually already done this one. 1/2 times 4 times 1/2 times 6.5. We've done this calculation once before today. We're going to get 6.5. Alright, so the volume of my rectangular prism. So for me, it helps to go ahead and draw out my rectangular prism. So this front face is what I'm going to call my base. And this front face is 4 by 6.5. So the area of my base times my height. Area of my base is base times height. And how deep does it go? Well, this also goes 6.5 deep. The base and height of my base are 4 and 6.5. So we're multiplying that by 6.5, which is how many layers of that we have. I have to throw that one into my calculator. 4 times 6.5 times 6.5. And that's going to give me 169 meters cubed. So if I want my total volume, I'll just write out this quick equation here. That V total is equal to the volume of the triangular prism plus the volume of the rectangular prism. So the triangular prism was 6.5 plus the volume of the rectangular prism, 169. So our total volume is going to be 175.5 meters cubed. All right. So as you're walking away, make sure that before you start your alone time, you and every one of your teammates has an understanding of how to find the volume of a prism, how to identify the area of the base and the height or the number of layers of that particular base. Once you've got that, please go ahead and move on to your alone time. Once you're done with your alone time, make sure that you're assigning yourself appropriately so as not to distract teammates. And just as a quick heads up, when we're looking at this particular problem, we're going to have to find the area of this base first, which is a little bit more complicated than any of the area of the bases that you have found so far. Notice that one way to find the area of the base would be to break it up into a rectangle and 2 triangles. So you might say the area of the base is equal to the area of the rectangle plus, and we can see these 2 triangles are exactly the same, so the 2 times the area of the triangles. So again, that's a conglomerated shape. This is something that we're really just practicing here, but once you find the area of that base, use that to help you find the volume. Alright, so again, once you're finished with the alone time, please go ahead and move on to independent work.